have a Patreon.
Did you see it? In the middle of the screen, what looks like a ghostly apparition appears to scream, "I have a Patreon." Is this real evidence of the paranormal, or just an elaborate ad to get more patrons? You decide. We're back, and I have cookies. Hello and welcome back to Uncovering Inventory Systems. Last time we made our interact system so we can actually interact with the objects we're creating, and then we created a parent item that holds all of our default values that are going to be across all items, and then we made our first subcategory, which is going to be a key item. And for fun, I'm going to go ahead and import a bunch of different weapons and RPG items so we can go ahead and create a couple more subcategories and then move on to the player actually being able to hold these items and them have a quantity. So I have imported a low poly Viking interiors. It is right here on the Epic Marketplace. I got it for free during one of the deals. There's tons of free assets on here if you need something within the marketplace. However, this is what I'll be using. You do not use the same static meshes. The meshes don't matter. The only thing you need to make sure is the meshes you're using are going to have collisions, so that way whenever you try to pick it up, your line trace by channel is actually going to hit it. Also, instead of cookies, I went with skinny dipped almonds. I'm going to be healthy. So if we go into the models, you'll see that I have some weapons to choose from. I'm going to go to the dagger. Sure, we'll choose one of the daggers, and let's go ahead and create a parent item for weapons. I will say this is where you actually need to get out a whiteboard, get out a piece of paper, do it digitally, I don't care. You need to figure out ahead of time what different type of parent items you're going to create so you can create a hierarchy that makes sense. For example, you wouldn't want your parent item to have damage, and then all your items, including potions, have damage even though you can't equip them in that way. But at the same time, if you're going to have multiple different types of items that have attack, you still might want to make additional branches out of a single sub-branch. So for example, these would be items that have attack, whereas these wouldn't. So for my case, I'm going to go ahead and create a parent class of just weapon. So let's right click our parent item. We're going to go up here to create child blueprint class, and we're going to name this BP underscore parent weapon. Control Shift S to save all. And let's go ahead and open that up. This is where thought being put into this is actually going to save you time in the future. Because immediately my brain said, well, wouldn't armor need durability? And since we're making weapons and those might need durability, maybe we need a subtree that encompasses all equipable items and not just weapons. Now don't get me wrong, if your tree isn't perfect and like you share a little bit of variables here and there, it's not the end of the world, but remember it's always good to strive for the best optimization possible while staying within scope in a reasonable amount of time. So let's just go with that idea. Let's delete the parent weapon. Let's open up our content browser. We're going to delete it. Instead, we're going to right click our parent item. We're going to create a blueprint, child blueprint. We're going to call this BP parent equipable instead. Control Shift S. Then in the equipable, we can do things that only equipable items need. Like for example, we can add durability. And we can change that to like an integer or a float, whichever you prefer. And maybe it needs to have a type. So we can type in the word type. Now we're not going to have a variable for this yet, so just leave it on integer and we'll explain that a little bit later if I remember. Let's go ahead and hit compile and save. Also, what I mean by type would be helmet, main hand, two hand, off hand, gloves, you know what I mean? So we'll close the BP parent equipable, and from parent equipable, now we'll create a child blueprint class. We'll call it BP parent weapon. Control Shift S, open it up, and now we see we have the durability, the type, the item name, and thumbnail, but now we can go ahead and add something like damage, and we can set that to probably a float, and Control Shift S, compile. I hope you're starting to understand why it's important to make that tree, preferably on a whiteboard or something so you can visualize it and start thinking about the stats you're going to need. so you can figure out what items can be contained under a similar blueprint. So I'll go ahead and create a new folder. We're just going to call this weapons. From weapon, we're going to right click and create a child blueprint class. We're going to call this BP Dagger 1. Kind of an uninspired name. Control Shift S, but we don't really need it to be anything special. Let's go ahead and drag that into weapons. And let's go ahead and set up Dagger 1. I won't spend too long on this, as you'll probably have different names and different meshes and things like that. Speaking of meshes, equipable items probably need meshes. So let's go back to our top level parent equipable item, and let's make it so all equipable items also have a static mesh now. I'm just going to call this SM equipable item. Pile and save. Also, this is an important time to mention, when you make these parent to child relationships, what's so amazing is, let's say I already had 50 different items created and I forgot to add the static mesh. I don't know how you'd get that far, but let's pretend. The reason it's so important and so nice to create a relationship like this in your inventory system is by adding the static mesh to the parent item, it's been added to all of them already. Now we have to specify which static mesh, but you can see how making quick changes is completely possible with a giant inventory of items. So if we go back to Dagger 1, you'll see now we have access to that static mesh. So what I'm going to do is, on the right hand side here for static mesh, I'm going to set it to one of the daggers. We'll just use Dagger 1. And now we have Dagger 1 set up as an equipable item with a static mesh. On the left, we can go ahead and set things like, how much damage does the dagger do? Well, let's pretend it's an early game item and it's a dagger, so it does 0.8. Also, that makes me realize, with the parent weapon, we could probably add like attack speed, right? How fast does it swing? File and save. And then what we can do is go back to our dagger, and now we can say, all right, I want you to swing it 2 times a second. So so we'll put it at 0.5, compile and save. Durability, we'll just set it to 100. Type, there is no type yet, don't worry. Item name, we'll call it the simple dagger. And I don't have a thumbnail yet, so let me go grab one. In fact, I'll show you guys how to make one in Engine really quick. If you want one for prototyping and stuff because you don't have an icon yet, or you can use it as a reason to, or like as an actual icon. Let's go ahead and drop the dagger into the world. In fact, I'm going to bring it over here so it's up against the wall, and you'll see why in just a moment. Like that. I'm going to spin it so it's facing like that. I'm going to press G, so that way, as you can see, when you press G in the viewport, it makes it so you're only seeing what the game sees. It hides all the other stuff. With it in place, now all I'm going to do is, if you click on this little sandwich menu at the top left-hand side of the viewport, you can actually go down to a high-resolution screenshot. I'm just going to leave it at 1. I'm going to hit capture. Then at the bottom right, it gives you a little pop-up of where it showed up at, so you can either click on it or you can navigate there yourself. And now we have a high-resolution screenshot of the dagger. Now obviously for a thumbnail, we don't want something this large, so I'm going to shove it into a cropping program really quick, and I'll use this as my thumbnail. So now that I'm in a program, what I'm going to do is I'm actually going to make sure it is a 1:1 image, because most thumbnails are square. So for me in Photoshop, I'm going to use the rectangular marquee tool. Style, we're actually going to go with a fixed ratio of 1:1, and that will make sure the marquee, no matter what, is a box. So we'll start somewhere over here, and we'll go ahead and get it about the right size. And then what I can do is, with marquee still selected, I can actually just move this so it's a bit more center now. And I could sit here and touch this up and make it more of a thumbnail, but I'm not going to do that. We're just going to go ahead and copy this. We're going to go to new, and I'll just paste it in, and there is the thumbnail I'm going to use. So I went ahead and just uploaded it, or imported it as a JPEG, which made it a texture. And now what I'll do is we'll go back into the BP. for thumbnail. Now, if we hit this down arrow on the right-hand side, it'll open up thumbnail, and we can go ahead and select things. So I'm going to open up image, and I'm going to type in dagger, and you'll see we have dagger 1 thumbnail. I will click it. Image size. Now you can do the exact image size, like you can see it automatically set this to 1058 by 1058, which is what we used. However, that's rather large. You don't really need it to be rendered that large. In fact, if I was going to make an inventory system for a real game, I would have probably exported this at like, at max, I don't know, 500 by 500, and that'd be like on the large side. So I'm gonna go ahead and just do that. I'm gonna set it to 500 by 500. Because it doesn't need to be that large. We'll go ahead and hit compile and save. And now we have a child of a child of a child that is a dagger. So let's go ahead and put that into a system that can accept it as an inventory item. Personally, I'm going to be putting this in my game instance. Now you might be wondering, why in the heck would I be putting this in the game instance? Well, the reality is, if you're making a multiplayer game or a single player game, if you take the inventory and place it in somewhere like the game instance, it's a lot easier for other systems to access it. Now, you can absolutely put it on like an actor component, so that way, if the actor component is present, then you know you might be able to loot that certain thing, like a chest. And that's a completely valid way to do it. But specifically for our player inventory, I'm going to be putting it in the game instance. And in order to do that, I need to create one for us to use. So I'm going to go back to my BP folder. I'm going to right click, and I'm going to go ahead and create a new folder. I'm going to call this systems. Within systems, I'm going to right click and create a blueprint class. And I don't think it's here. Nope, it is not here. So what we're going to do is we're going to open up all classes, and I'm going to type in game space instance. And I'm going to call this GI, and then normally the name of the game. So like game instance underscore name of the game. So we'll just call this GI inventory. Now, this is not an inventory. This is the game instance. I'm just naming it inventory because I'm making a YouTube video about inventories. Don't get confused. Let's go ahead and open it up. You'll note that you get basically an empty blueprint. So for those that don't know, what is the game instance? The game instance is something that is running at all times whenever you are playing a game. It's the thing that kind of keeps track of everything, if you choose to use it that way. Think of it as a blueprint above all other blueprints that you can just access. So it's kind of like having global variables almost. And important step, after you create a game instance, you need to go to your project settings. So if this isn't open for you, you can go to edit and then project settings, but mine's already open. And within here, if you type in game instance, you'll see that it says game instance class. And right now it's set to whatever the default is. We're going to open that up and we're going to change that to our newly created one. So that way the game instance is the one we want. All right, so back over in the game instance, we are going to go ahead and create a map. A map is actually what is going to be used as our inventory. So for example, if we go over here to variables, I can go ahead and hit plus, and I'm just going to call this player inventory. And for the variable type, we actually want the parent item, but like the big main one, the BP parent item. And it's actually, this is one of the rare cases where you're not going to do an object reference. You're going to do a class reference. What is the difference between an object and a class reference? An object reference needs to exist. So for example, if you want an object reference to a dagger, one needs to already exist in the game world. A class reference is more of just saying, I want you to have the dagger loaded as like its class and everything, but it doesn't exist yet, so just kind of have it ready. That's the simplest way I can put it. So now that we set this up, we're gonna go to the right-hand side, and you'll see we have this little drop-down arrow here. Normally, you would do this to go to array, but instead we're gonna go to a map. Now you'll see that we have a BP parent item class reference and an integer mixed in one variable type. To put it simply, the BP parent item is going to hold a reference to the item, and the integer will hold the quantity. So for example, if we had 3 daggers, the inventory will simply have a reference to the dagger class and a 3. However, we need a way to add items and remove items from our inventory. Let's go ahead and start with adding items. I am going to create a function within our game instance, and this function is going to be called add. Actually, you know what? I've changed my naming conventions a little bit. I like to know what it's for immediately. So instead, I'm going to name it inventory, right? Because we know what it is now, underscore add. And we are going to require 2 inputs. We need a parent BP, like parent item BP class reference. And we will just call this item. And then we need the quantity, which you can set it to a float if you want your inventory system to work off floats. I prefer integers, so I'm going to go with an integer. And by the way, if you do want it to be floats, your map has to have floats as well. And then I'm actually going to require an output as well. So I'm actually going to make the output named success, and it's going to be a Boolean with compile and save. The reason for this is because if it gets to the point where it's like, hey, you've set a maximum inventory count, we can't add any more items, that might be a reason we would want to return that it wasn't successful. For the time being, we are going to make it very simple. We are going to grab our player inventory. What we're going to do is we're going to pull out of the map, and there is something called contains. What this is going to do is simply return a true or false on whether it already exists in the inventory or not. And what we need to do is plug our item from the incoming function. So now whenever we call this function, the item will immediately be checked if it's in there or not. So let's hit a branch by holding B and clicking, get our execution pin plugged in. And I'm going to right click on the branch because I always like to leave node comments on branches. And this is simply going to say, does the item already exist in our inventory? And we will plug that result into the Boolean. So the reason this is important is because if it already exists, we need to add the integer to the current map instead of replacing it. Because when you add a class to a map, like let's say you add class dagger with integer 5 to the map. Well, if you add dagger again, but with a different integer, it will replace the previous one. Suggested it does indeed exist. What we're going to do is get another reference to our inventory, and we're going to pull out and we're going to click on, or we're going to type in and click on find. So the difference between find and contains is whenever it does indeed find the item, it's also going to return that value, specifically the value that we've set as a quantity on the map. Now, you can plug item directly into this find. However, a neat trick with functions that's very important to keep things clean is because the item is an input to the function, we can then reference it as if it was a variable. So I can now just do get item, and look at that. I can get it as if it's a variable, and it kind of saves you from having strings everywhere. Just for debugging purposes, we are going to do a second branch. It's a little unnecessary because we did do a contains here, but we have the result here in case it wasn't able to find it, so we might as well run it one more time. We're going to run our true up to this branch, and I'm going to name this one, could it find the quantity? And let's say it gets to this point and fails. We're just going to do a print string, and it's just going to say, failed to find quantity of item. And actually, what I'm going to do, instead of just typing in the text like this is actually a really good lesson for those of you that want to learn how to debug. I'm going to right click, I'm going to do format text, and watch what we can do. So I'm going to type in here instead, failed to load quantity of item. And then what I'll do is I'll put a colon, And then I will create a curly bracket and say just item, and then another curly bracket and press enter. So now what it's going to do is, you see we have our text that we created, and inside the curly brackets we put item. Well, now we have an input for item. So the reason this is important is we can get our item and just do like, watch this, get class name, get class display name. We can plug this in to item and then plug this in to our print string. So this will help us debug. If something happens that makes it so even though it contains it, but it was unable to find the quantity, it's going to run a print string that says failed to load quantity of item, boom. And now it'll give us the display name, and that will help us debug any issues that we get. I hope that makes sense. However, we are expecting it to be able to find the quantity, which is right here. And what we're gonna do is we're gonna make it a local variable, and I'll explain why in just a moment. However, to make it a local variable, right here, we're gonna pull out and let go, and you'll see we have promote to local variable. Then we'll plug true into the execution pin, and I will clean up my wires here in just a second. However, on the left-hand side, you'll see we have a new local variable. If you click it and press F2, you can rename it. I'm gonna name this current amount and hit compile and save. So the reason I'm saving this as a local variable, first off, a local variable takes place only inside of a function. And as soon as the function isn't running, the memory completely forgets it exists. So it's really optimal to use local variables inside functions whenever you can. The other reason I am setting this as a variable instead of like, let me show you. Instead of just doing this, like pulling out and typing in add, because spoiler alert, that's what we're going to be doing, and then we add like, I don't know, like 50. This is just a random example. Is because sometimes if this is running like 3 times in a row, I've had weird issues where wires get crossed and it adds the wrong number together because it ran like 3 times, and for some reason the find would find like the second item whenever it was doing like this calculation and then blah, 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 blah. So instead, what I do is each time the function runs, it saves that amount temporarily. So that way we know we're going to be getting the correct amount when we do the calculation. I hope that makes sense. Compile and save. Fix my wires real quick. Okay. So we know that we now know the current amount that's in the inventory. We know it's in the inventory, and we know the amount that's currently in it. So let's take that amount, add the incoming amount, and then reset it into the inventory. So in order to do that, if you remember, the incoming amount is a input, which means we can use this like a variable. So what I'm going to do is take current amount, I'm going to pull out and type in add, and then at the bottom, what I'm going to do is pull out and type in quantity. Let's remind ourselves what's happening. This is how much is currently in the inventory. We're adding the incoming amount. And now let's get another reference to our inventory. And we're going to pull out and we're going to type in add. So that way it looks like this. We're going to take our execution pin, connect it. And remember, the incoming item is an input, so we can use it like a variable. We're going to pull out and type in item. And the quantity will be the current amount plus the incoming amount, and that is our new value. So this might look confusing if you're not used to maps. These don't work like arrays. If this was an array, all we would be doing is adding another instance of the item with the new amount. But that's not how maps work. How maps work is because this class already exists, by adding it again, we are replacing it. So do you see? We got the amount that it's currently at, added, replaced. However, I'm going to go ahead and use my space. Something you can do to really make your code look a lot more clean is to use the space given to you. So let's go ahead and move this out around a bit. There we go. See how I just kind of moved it all apart, so therefore it's taking up more space, but it's a little easier to see in distinguished groups. So for example, now we can grab this section, press C to create a comment, updating the amount of the item. Grab this, debug in all caps, forward, or space, dash space, that's just kind of how I do it. Error handling, and since it's debug, I like to just go ahead and make it orange, so just kind of put it down here, put red at 1, put green at 0.5, hit OK. And of course, on my comments, I also like to show bubble when zoomed. And look how much easier it is immediately to tell what's going on just by looking at it at a glance. Pile and save. Which, by the way, at the end of the ad here, take your return node, and if you don't have one, you can just right click and type in return node and press enter. And let's add a return node with a success on it. After the print string, which hopefully never gets called, I'm just gonna copy paste so it's easy. We're gonna pull this out, and we're actually gonna do a fail because obviously we never updated the inventory. So here it failed. Pile and save. Okay. But what happens if it doesn't already exist? Well, luckily that's where it's really friggin' easy. We're gonna get another reference to our inventory. You can copy paste or do a git. We're gonna do an add. We're gonna plug our execution pin in and simply pull out and do git item and git quantity. We'll hit compile and save. And we need to add a return node. So out of the execution pin, I'm just going to type in return node. And in this case, it would be a success. Grab it, comment, adding new item to inventory. And there you go. You made your first basic function for your inventory. Now we're going to go ahead and update this as time goes on. This is very basic. It's not looking for how big the inventory is. It's not looking for stat counts. It's not looking for any of that. It's just saying more stuff's coming in. Great. Let me add it to the map and or update the quantity. However, we are going to go ahead and stop here for now. These videos are very dense with information, so I apologize. I know you're probably impatient, really wanting that inventory system complete. I get it, but I hope you're learning something, and I'll see you in the next video.